Hi everyone, we are going to have our next tech talk in 2 minutes, so keep with us. We're going to have 2 presenters. It's going to be a bit different from the past. And on our next tech talk is going to be with Yuri. He's going to talk a bit more about how to do a free API using GraphQL in AWS. So I want to give a welcome to Yuri. So I'm going to let you, Yuri.
Thanks,
This is
Gabriel.
showtime.
So, hello everyone. Thanks for being here. In this presentation, we'll discuss a little bit about how to run a free API in AWS using GraphQL. Just so you see how the presentation is going to be, I'll start telling you a little bit about me. Then we'll talk a little bit about motivation on why to run this free API. Then we are discussing, is it really a free API? Then just a quick explanation on some concepts of GraphQL. Then we're going to look in code. Then an architecture overview. I'll show a model that is most commonly used, and then the model that allows this API. Then a cost comparison between the model, the old model and this new model. Some limitations we have. A benchmark, so we have some sort of view on performance for this API, and then a moment for questions. For everyone that's here, I ask gently to hold the questions until the end of the presentation. And for the YouTube live, then you can post in the chat anytime. So, about me, just a little bit, because it's hard to say everything that is to say in this presentation. But I'm Brazilian, and I've been living in the Netherlands for 4 months. I am a series and movies lover. Also, I am a light gamer. I don't call myself a gamer because I'm not so engaged, although I love gaming. And also, I'm recently married. I've married 1 month before coming to the Netherlands. Then just some pictures. It's important to show to you guys because it's a huge moment for me. And now more in a professional side, I have 4 years of market experience. I've been a developer for 10 years since I started a technical course in Brazil. I love to learn and share knowledge. This is one of the big reasons why I'm here today. And also, I am passionate about code and digital solutions. And my goal as a professional and also as a person is to make good impact in people's lives. Then, okay, uh, you're probably saying in your mind now that, okay, it's not possible that my company's API that runs 1,000 requests per second is going to be free. And that is true. But then why? I understand if you guys are like John Travolta right now, because why am I watching this? But then I have this API for myself that I developed to keep track of my savings goals. I want to save money for stuff, to buy stuff, or for an emergency, for example, and I have and I want to have money saved for it. Now, imagine yourself getting married, planning a whole travel abroad, to live abroad, and then you arrive in this new country, you start setting everything up, you find a long stay place to live, and then comes a $50 charge in your credit card. And this charge is from AWS. Yeah, this happened to me. This API that I had relied on resources that were 12 months free in AWS, and then this time for 12 months ended, and they charged me for the resources of this API. So this is the first reason, because it enables personal projects, personal and also small projects. And also it's cost efficient. So you are not going to pay for what you're not using. In this case, I wasn't using the API that much, but still I got charged in full. And yeah. Then, is it really a free API? Here I want to set some expectations, just so I keep transparent with you. But it's serverless. In this case, function as a service. So it's a good start for it to be free and also cost efficient. And I can guarantee you that the core tools for this API are always free. Some optional tools are 12 months free. But just for us to think, when we say always or 12 months, it's related to time. But when we say a number of requests or required resources, it's about volume. So my conclusion here is that, yeah, this API is not Dobby, but it's free, but with limitations. So, and we are going to discuss these limitations in another moment in this presentation. So, GraphQL. We'll walk through some concepts. First, what is GraphQL? It's a server-side runtime and query language. It runs in HTTP protocol. For GraphQL, it only uses GET and POST requests. It runs in a single endpoint, and for a free API, it kind of helps because there are some overhead when we have serverless functions, Lambda functions, for example, that is code starts, for example. And having a single endpoint means we only have one function for our whole API, and this kind of helps to handle code starts, for example. And then GraphQL is a shared language. It has a shared language between your consumer and producer of the API, can be your front end and back end. And this shared language helps to keep the communication straight between the 2 points, but it's not bound to any programming language. So you can have your back end in JavaScript and then your front end in another language. Also, you could have your backend in another language. It has powerful schemas and query language. I'll show you a little bit of the schema and the query language. and it helps to achieve a versionless API. When changing the API can cause errors in the consumer, it means that every change is possibly a breaking change. So the default behavior in GraphQL, actually in GraphQL, it's mandatory to describe what fields you want to fetch. Then adding a new field in your API, for example, is not going to break the communication with the consumer or the front end. This is why it makes less likely to generate a breaking change in your API. It doesn't mean that it's breaking change proof, but it helps. And then some core concepts, just a quick overview. A schema. The schema in GraphQL is the definition of your API, how and what you can do with it. There are entities. The entity is a type within your domain. The entity graph, it's pretty much how those entities communicate between them. We have the query, which is used to fetch data. And we also have mutation, which is used to change or update data. So just a little analogy with REST, which is more common to us. Then the schema, we could say it relates to the interface. It's not really, because the schema is more powerful and it's part of the shared language, while interfaces are bound to the programming language of the backend. We also have entity relates to REST resources. Entity graph relates to routes or URLs. The query is pretty much the resource fetching, and mutation is pretty much the resource creation or update. Then just a little bit of the anatomy of your request. It's a HTTP request, and it's very similar to what we know. The method is going to be post or get. The headers, you have a content type application JSON. GraphQL normally runs in JSON, so this is why normally there is this header. Also, we have the body, which is a JSON body, but the query, this query field of this JSON is a string that looks like JSON, but it's not. So the content here of this query is part of the language of GraphQL. And then so you guys have a look of how the code looks. Here, a tip here. There is this Zen mode in VS Code that you can use to focus in your code. I really like to use it when I just want to focus on my code. And here, this type devs here, all this thing is our schema. Until the bottom, it's our schema. To define the schema, we use this GQL function, which is from this library, Apollo Server Lambda. And this code is in JavaScript, running in a Node.js environment. And then we use this function to define our schema. First, I'm defining the goal of my API. Since it's a savings API, something that I want to keep track of my savings goals, there needs to be a goal. This goal has an ID, which is of type ID, which is pretty much a string that means that it's unique. Also, we have a title, which is a string, a saved amount, how much have I saved so far for this goal, which is a float, a target amount, how much I want to save for this, a description, maybe I want something other than the title to describe this, and also the target date, when do I want to have saved this target amount. And here we can start seeing why the query language and schema of GraphQL is so powerful, because here, already in the schema, we define, for example, that this ID is not null. which means that every time I query for a Go and I fetch the ID is not going to be null. This is the same for the title. It's not going to be null. So I always have a title for my goals, and same for saved amount. In this case, for saved amount, it's a rule for me to not return a null, for example. If I haven't saved any money so far, I want to return 0 instead of a null. For the other fields, it's okay for me, so then I don't define that they are not null. And then here, we have the type query. This type query is it's from GraphQL. When I define this here, everything that is inside is are parts of my are queries that I have in my API. In this case, I have a Go query, which fetches and Go by the ID. And also here I can define if it can be null or not. In this case, I don't want it to be null. If I'm going to fetch a Go, I want to have the ID of this Go. But here I can respond with a null. In case, for example, the ID doesn't exist, then I'm going to return a null Go. Then I can also fetch every Go that I have in my system. And in this case, it's an array. I'm defining here that this is an array with these brackets. But also here, it's an array of non-null Goals. And then we have a non-null array. So what I'm saying here is that if I have anything inside my array, it's not going to be null, but also I will always return an array. If I don't have any goals in my API, then it's going to return a empty array. And I can define all of that in my schema. And here we have the mutation. Everything that is inside this mutation type is going to be a mutation that there is in our API. In this case, we have the mutation to add and go, which receives every field of the Go type, but they are not really defined the same way. Here I define that the ID is nullable. I want, for example, if no ID is provided to create an ID in my backend, but when I create a Go, I always want to have a title. No, it makes no sense for me to have a Go with no title. And for the saved amount, for example, that is also no in the also not no in the Go. If I don't pass anything here, it's going to be considered 0. And then it returns a Go that respects this type here. Okay, and other than the definitions, the schema, I need to declare my resolvers. And those resolvers are pretty much the implementation of my queries and mutations. Just an observation, the names here needs to be the same names that are defined here. So if I have a query Go here, it has to have the same name here. And for my mutations, the same. I have edge-go here, and I must have edge-go here. And then to enable the API, we just need to create this Apollo server class. We need to create an instance of this class and export this server.create handler. And then our Lambda function is ready to run a GraphQL API. And just so we have a look on how it looks to query stuff, GraphQL, we have this API. First, I want to start adding a Go. So first thing that I want to show you is this schema fetched thing. It means that a Postman already understands my API. And this is one of the powerful stuff about GraphQL. It's the shared language thing. The Postman can understand my API, and it doesn't really need to understand JavaScript, for example. And here is when it comes to help. Then we have autocomplete in our Postman. And it also helps with our fields. Then I don't want to add a Go with a ID, but I want to have a title. I want to buy a PlayStation 5. PlayStation 5. So my target amount is 500. And also the target date will be my birthday this year. So it's going to be 2022, August 18. And then here I need to query what fields I want in this response. In this case, I only want my ID because I'm going to fetch this guy. Then, if we see here, then I created my goal and it has the ID. So I'm copying this and I want to fetch it with my Go query. And here is, I also have autocomplete for this. And then my ID here. Here I want to, sorry. Here I want to have my ID, my title, how much I've saved so far, and when I want to have it saved, for example. And then it brings me all the fields that I fetched. Last, we have the one that brings all goals. And then here I only want the ID, the title, and the target amount, for example, target amount. And then I can send, and those values will be fetched. So we have a lot of different queries that we can make with only one schema or only with only one type. And then if I add a new field here, then it's not going to break this query. Okay, then we go back to the presentation. Okay. Then a little overview of the architecture. Here is the architecture that I had before. I changed to this new architecture, which is pretty much very common. We have an load balancer here, an application load balancer. We have a EC2 instance and an RDS. In this case, it's Postgres. The thing about this architecture is that every resource that I have here, I have to pay for them even though I don't use them. If I don't request once my API in a month, I'll be paying for those resources. And here is how it looks now. I wanted to keep this in the left, this thing in the left, because it's our local architecture, how to test it locally. I wanted to keep it here because sometimes it can be hard to test Lambda functions locally, but we have some tools that help with that. I'm not going to enter in details, but it's good to know that we can test these Lambda functions locally. And in here, we have the architecture in AWS. First, we have a API gateway in front of the Lambda function. Then it calls a Node.js Lambda function. And we have this DynamoDB table. And the good thing about this is that we only pay, it's all serverless, and we only pay for how much we use it. So I'd probably be charged 0, even if it wasn't free. But then a little bit of cost comparison. Since we're talking about a free API, it's important to have this comparison. If we consider an API that handles 1 million requests per month, and is also 24/7 available, we have this view. The Lambda functions are going to cost nothing for this 1 million requests. Also, DynamoDB will be free, and the logs will be free as well. Here we have the API gateway. For 1 million requests, it's going to be paid. But it's not mandatory. It's possible to run this API with this API gateway, without this API gateway, but I highly recommend to keep it. And then we have a total amount of $3.5, including the optional tool. And then we have our old architecture. For the EC2 instance, this is for one EC2 instance, we would pay $9.27. For the load balancer, it's really, really costly. we would pay $22.27. And for our Postgres database, we would pay $14.06. And also for logs, it's 0. Just one remark here. You'll probably see this yellow exclamation point. It's because CloudWatch logs can become very expensive fast. So if you have a lot of logs in your application, watch out for this guy because it can be expensive. But for a small API, it's probably not going to cost anything. And then we have a total of $45.6. And then this is what happens when we switch from ECS to Lambda. Yeah, we have a free API. Then we need to talk about some limitations, because in Brazil we have this saying that is, não existe almoço grátis, which translates to there's no free lunch. So yeah, something has to be limited. Otherwise, also AWS would be bankrupt by now. Then let's talk a little bit about how it works for AWS free tier. First, we have the model of free trials, which is basically some short-term offers for some specific services. And they start counting when you start using a specific service. We have some tools that are 12 months free, which means that these 12 months start counting when you create your AWS account. And then we have some tools that are always free, which means that for how long you use it, you're not going to pay to use it, only to use it. But we have to discuss volume and limitations in volume. For Lambda, we have a limitation of 1 million requests per month and 3.2 million seconds of compute time. This compute time is a calculation based on how much memory you use for how much time. But just to give an example, if you have a Lambda function that is configured with 512 megabytes of memory and it runs for 500 milliseconds, then you can handle 800,000 requests a month. But if you use less memory, then you can have more requests, but always keeping in mind this 1 million free requests per month. Then we have our DynamoDB table. DynamoDB has a 25 giga of storage for free, 25 provisioned write capacity units, and 25 provisioned read capacity units. It's not so, the calculation for this is not that simple, but we can consider that it handles 25 read and 25 write requests per second. AWS says that this is enough to handle 200 million requests per month. We have CloudWatch logs. There are some limitations here, but the two most important ones are the 1 million API requests and 5 giga of log data ingestion and log data archive. This is probably the one limitation that you need to be aware of when you're running a API that logs a lot of stuff. This is pretty much how much log data you can have. And then for the API gateway, we have 1 million requests a month for free, but only for the 12 first months of your account. But even for API gateway here, if you have 3,000 requests a month, you're going to be paid 1 cent a month. So it's if you don't have 3,000 requests a month, you'll probably be paying less than 1 cent a month. And then a little tip: when you're starting a personal or small project, it's nice to have a look at AWS free tier page, so you can possibly run some tools for free. Well, then the benchmark. Is this viable to run in production? I'm not going to answer this because it depends on the context that you have. But here is a performance test that I ran in the API running in AWS. we had 50 virtual users running for 5 minutes. So the 100% requests succeeding. We had a average response time of less than 200 milliseconds. We had 95% of our requests answering in a little bit more than 300 milliseconds. Our biggest response time was of 1.42 seconds. And we had 41 iterations per second. So yeah, it looks really good for me. And then it's the time for questions. If there are any questions in the YouTube, they are going to tell me. But here, do you guys have any questions? It's time to learn even more.
I'd like to thank you, Yuri. And yes, we have a question from Tato. So his question is, what happens when I have to provide a less field for the goal? For example, if you want to reduce one of the fields from the goal, what is going to happen? Is it going to be a breaking change? What's going to happen with the API with GraphQL?
Yeah, in this case, if we have less fields, and I'm querying for this field, and the schema is not updated, so it doesn't break any of your tests, then it's going to be a breaking change. This is why it's not breaking change proof. But since you have this schema, you probably know this upfront. So some tests of you will probably get this, and this breaking change won't go to production. But yes, in this case, it happens a breaking change. Thanks for the question, Tato.
Actually, Matt, I have a question that it's the next question from Tato. Actually,
perfect.
Is it possible to versionate the GraphQL APIs? Because okay, if I have a breaking change, I want to keep the old schema, but I also to introduce the new schema.
I'm not sure about the details in here, but it's not mandatory to use this only one route in GraphQL. And also in API Gateway and also in Lambda, you can have different versions of your API, and AWS helps you handle this.
So
yeah.
You handle the API Gateway.
Yeah. Then you can also have different versions for your test environment or your development environment. So you can handle this, for example, in the Lambda part, not really in the GraphQL, but probably you can also do this in GraphQL.
Okay, thank you.
No problem. Thank you for the question. Then, any more questions?
Yeah, we don't have any more questions, at least from YouTube right now.
Okay.
I'd like to thank you, Yuri, for the presentation. It was really good.
Thank you, Gabriel.
It was a really nice presentation.
Yeah.
This is to bring a bit of awareness, I think.
Yes.
Yeah, to GraphQL, and also a bit on how to use the resource from AWS in a cost-effective manner.
Yeah,
yes,
exactly.
That's really nice.
The idea is not to have like a free API running in your company with a lot of requests. Just stay tuned in the blog, because there will be a post coming next week about this subject.
Yes.
And thank you very much all for watching this presentation.
Follow us on a Medium publication.
Yes.
And yes, thank you.
Thank you guys.
This is visual. Everyone, in 2 minutes, we're going to have another Tech Talk. This is going to be a Tech Talk from Daniel. He already did Tech Talks before with us, and this time is going to be how to make a Telegram bot using AWS, and this is a bot that's scalable and reliable, so keep with us. Okay, everyone, we are going to be live with Daniel's presentation in 1 minute. He's just fixing up his Telegram account here to show us this amazing bot that you also at home can interact with it. So keep an eye on it. Hi, everyone. Now we're back with the presentation from Daniel. Daniel, the stage is all yours.
Thank you very much. Hi, everyone. Thanks for having me today. We're going to talk about how to build a scalable and reliable Telegram bot. But first, let's introduce myself. My name is from Poland. I'm from Brazil, but I live in here in Eindhoven for about 8 months. Some cool stuff about me. I got married in a hot air balloon. I've been traveling with my kids in Dutch. They already speak Dutch and I don't, so it's really funny for them. But not so cool stuff about me. I'm a software engineer here at WAES, and I am cloud and DevOps enthusiast. That means that I really like the themes and try to study and apply as much as I can. Today we're going to run through these steps. First, we're going to talk about how Telegram bot works. The second, we're going to talk about the architecture overview. Then we'll go through a demo. That's the most part for the presentation today. And the costs. That's it. Telegram bots. What is and why? Telegram bot, it's online messaging app, right? It's not so surprising. It's not different. It's just like WhatsApp or Facebook messaging. So yeah, no secret in there, but why? It's obvious because these cute icons they have on the web page. Yeah, this is really cute. If you go to the Telegram web page now, you can see them there. But really, this here, we are going to have, they have open API and source code free for everyone. And this is also a good looking icon, but actually they are the free APIs that you can easily use. And it is really easy. We are going to show here, we are going to build our Telegram bot, and we can monetize our bot or application. So we can earn money from that. If you have a good idea, you can use Telegram bots as your front end, and you can just develop your backend. So that's nice. It's written in their terms, at least till today. They can change it every time, but you can earn money from that. And how it actually works? Well, you need to configure it first, and actually it's nice or creepy, depending, but because you need to use a bot to create a bot. So yeah, we're going to see how it works. And the second configuration step, you need to configure how do you want to receive your messages. There are two options. The first options, API calls. Okay, so I'm going there, hey Telegram, do you have a new message? Hey Telegram, do you have a new message? I don't like that because I need to keep running stuff. So I would prefer, and we are going to use the webhooks. That means that Telegrams will send the message for us when we have one. So it will provide them an API, and they will use it to send message for us. And the usage steps, okay, we are going to receive a message from Telegram. We are going to process the message. It's a really simple process today because it's a demo. We're just going to answer saying, hey, you typed whatever you typed. And actually, you're going to then you need to call Telegram API to send a new message for them, right? So it's abstract, but we are going to do a demo here. It will be nice. So we are going to see how it works. Architecture. Let's talk about some goals and characteristics that we want. The bot should be reliable, right? And when I say reliable, of course, you need and you can have reliability on your code. But we are going to use here the cloud provider service reliability because it's there. We can use it, right? So we are going to use that. The bot should be scalable. And here, it should be scalable as hell. And you can scale, or you can put a limit. Okay, let's scale like this, because if I scale too much, I will pay too much, right? So the bot must be scalable, and the bot should be cost effective, because if you have a business, you want to have profit. If you're doing a personal project, you don't want to spend so much money like Yuri spent last time. He said that. So I already been there, so I know how it is. And we have these characteristics. We have asynchronous communication, because except for my mother, no one expects that you answer a message in this next 1 millisecond, right? You can take, well, people take 1 hour, I take 1 day, depending on the person that sent me the message. But yeah, actually, our bot can take 1 second, 2 seconds. Yeah, that doesn't matter, right? It's a bot. It's a asynchronous communication. And when I think about reliability, scalability, cost-effective, and asynchronous, I think in a serverless architecture. Yuri just explained it very beautiful. How does it works? We are going to use it here, so it will be really nice. And you can host it in every cloud provider that you want. Google Cloud, Azure, AWS, all of them have this service, but my knowledge is more focused on AWS, so we are going to also host here in AWS, and we are going to show them, right? So let's go for the diagram. No, it's not so complicated like that. It's actually really simple. We can make it complicated, but we won't, right? We are from IT, and we can make everything complicated if you want. But let's go into first talk about what we want for our diagram right now. So when I talk about asynchronous, the first thing that comes in my mind is, please audience, is?
A queue?
Queue, exactly. Thank you so much. Yeah, a queue. So we are going to start with queue from SQS, from AWS, and we're going to choose SQS. And it would be really, really, really nice if Telegram could post a message directly to the SQS queue, right? Because I don't need any transformation. I don't need anything. I just need a message in the queue. So, yeah, we can do that. SQS demands authentication. SQS demands a specific payload, a specific headers. So we can do that. But we have a few options. The first option, we can have a Lambda function here and receive the request from Telegram using the Lambda function. It's good, but I don't want to pay. I really don't want to pay. I don't want this time process, and I don't want to use computing service to not compute, because I just want to SQS. So we will post from API gateway directly to SQS. And this is, I think, the most interesting part for this project, because some people don't know that's possible. It is possible without just configuring the API gateway. We can post it to SQS. In Brazil, we say pulo do gato. Here, it's a jump of the cat. It's a trick. So let's do that here. Well, now I need a Lambda function to process the data, right? Now I receive the message, I want to process. Here, it's going to be a really, really simple processing. We're just going to answer a string. But actually, you can use intelligence artifice or something that you want to process your message. Then we could actually send the message back to Telegram to answer, right? But we are not going to do that. We are going to increase a little more the diagram, increase the complexity, sorry. Why? First, Lambda functions are meant to be small. If you can split the behavior for your functions, split. Okay, so that's the first rule that we need to follow. So here I have a processing. Here I will have the response, the lambda that you care about the response. So two different behaviors. So I'm going to split. But if we think further and think, okay, let's say that now that I have a lot of people using my bot, I want to send active message. Say, everyone's in a day, send, hello, this is the last news for us, or hello, I don't know. Everything you can think in advance for a business. I will just write whatever I want here and post to this SQS. I don't care. This Lambda function will handle. So that's why we split this into Lambda functions, right? So that's it. Let's go for the demo. First, let's here. I have this GitHub page because my memory is not so strong, and I here have all the steps that they're going through. And the one thing that's important, names are important here. Why? Because I already configured all the permissions using these name patterns, because we won't have time to this demo to configure all the IAM permissions. So if you want to talk about IAM later, please reach me and we can talk about it, or yeah, today or whatever other day. Okay? And here we have our AWS console. Don't know if you already have seen this, but it's really simple. If I want to go to SQS, I just came here and go to SQS, right? Let's go to our diagram again. And come on, please. Okay. So we start with SQS, right? So let's start with the SQS in here too. Create a queue. I won't go through all the options because we don't have time. But one thing that I'm going to change here is the type of the queue. I would like to have a first in, first out queue, because ordering for me, it's important. I want to answer the first message that I receive, then the second message that I receive. And for me, it's important to have a first in, first out queue. So let's go here and let's check. Come on. Let me split this one. Sorry. I'm going to, so I can use the alt tab. Okay. So have the inbound SQS queue, and it needs to have this name because of the permissions. In your case, if you're going to try to reproduce this demo, it's not necessary, but you need to care about permissions. Don't forget it. Okay? Yeah, simple like that. I have first in, first out queue, and with the default configuration, right? So the next step we have, it's the API gateway, right? So we're gonna need to API gateway to post directly to SQS. So let's do it. API gateway. Oh, sorry. API gateway, posting directly to SQS. So here we are going to create our API. There are a lot of types of API gateway that you can create, but again, unfortunately we don't have time, but we can talk about these steps later if you want. Then we are going to a new API from scratch. API name. Again, names are important here, so copy, paste. I want regional. I don't want to CloudFront optimize it. I need it public, so let's go for the regional. And okay, I have my API gateway. Now, when I have my API gateway, they have the URL, something.aws.com. But it's nice, so you can manage to have a slash something later, right? Here we call resource. So let's create a resource. And for the resource, I'm going to use this name in here, right? But I really don't like this name for the path, right? For the URL. So we're going to use a word that I always use in Brazil, and I'm going to use it here, batata. So now, every time you hear about batata, you remember about this presentation. Batata means potato in English. So batata, B-A-T-A-T-A. It's easy, it's short, and you remember about me every time you see that. So that's nice. Let's say here, batata. Okay. So let's create it. Okay, now I have my resource. Postgres demands a post resource. So we are going to go here, come here, and create a post method. So we're going to create a post method and create a post. And there it is. Now, we are going to send the requests to a AWS service, right? I promised that. So we are going to use here AWS region. That's really important. I hope I'm Ireland here, right? Yeah, so we are going to host our application in US1, right? So our application is there. AWS service, well, SQS. Come on, come on, come on. Here. We're going to leave it blank. API gateway will post to SQS. Path override. I need this one because it's my account ID and the FIFO queue that we created. Please don't hack my account ID. I will need another account for AWS. Yeah. Oh, thank you very much. It's US1. Yeah, thank you very much. US1. And for the execution role, remember, I already created my role, and this solves the part of the authorization, right? So now API Gate will have the correct authorization to go to the SQS. So yeah, let's do it. Okay, this is the API Gate interface. Let's test it, right? And let's send here, test, request body, and it failed. Why? Because remember, I said that SQS demands a specific headers, a specific body. We just created an integration. Now we're going to configure it to send the specific headers and specific body. So let's do that. So here, integration request. So for the headers, right? For every request, I'm going to send a specific header. And the header is for the front-end developers. No, not this one here. For the front-end developers and also back-end developers knows this content header, right? So that's content type and the form header. I don't know. I think this mouse just screwed a little. Yeah. Let's check if there is no blank space. No. Yeah, I think here there is a blank space, right? Yeah. So application undercoded. Yeah. Let's save it. Okay. Now for every request, API Gate will send this content type. And the body. Let's care about the body. So with this configuration, let's just type here, application /JSON. It's correct. What I'm doing here, I'm setting, okay, everything that comes with the content type application.json, I'm going to handle it. If it doesn't come with whatever other content type, I will reject, right? That's why I'm using this option here. So I'm going to save. And here, it's actually the body that I'm going to send to SQS. So I have here, let's just copy and paste, and I'm going to read with you in a moment. Okay, then let's zoom in. I think it's better. Action, send message. Actually, it's what we want. Message group ID, message deduplication ID, it's queue stuff. But here, it's really important. Body. We are encoding base64, the body. Why? Because Telegram will send a lot of special characters and you break it. It happened. I tested. It happened. It breaks. So we are going to base64 encode here, and we need to remember to decode in our code, right? So, but let's save it here. Okay. AWS is strange, but it's saved. It doesn't just say any message, but it's saved. So let's test again. And work it. We have our answer for SQS, right? But it's a demo. I need to show you that it worked, right? So let's come back here to SQS. Send receive message. And I have one message available. So I'm not aligned that's working. And I have this. And if we go to base 64, oh, in my laptop, I already have this one, sorry. Base for the code, yeah, this one. Okay, I agree, sorry. If you go to the code, come on. I have a test. So it worked. The message that I sent to the API gateway went to the queue. So, okay, That's really, really good, right? And easy. With just some few configurations, we have our API gateway posting direct to SQS. But actually, we don't have an API gateway deployed yet. Let's deploy this API gateway so we can have a URL that we can actually call. So this will be our production environment. Don't do that. Do not develop in production, but here we're going. So now we have a URL. It's deployed to the internet. Okay, then we have. Let's go back to the diagram to see where we are. We are at this phase, right? So we have the API gateway. We have the SQS. Let's start now with the Lambda function. So let's go for the Lambda. And let's create our Lambda function that will handle the request. Function name. Again, in this case, names are important because of the permissions, but if you're creating your own project, you don't need to care about. Node.js 16, it was released last month in AWS Lambda, so that's new. Change default execution role. Again, I have created my permissions in here, so let's just use it. Okay, create function. So we have our Lambda function created. Now we need to upload our code, right? Let's upload our code first. Zip file, upload. Now we need to find our download, telegram.demo, blah, blah, blah. This is the inbound function. That's the function that will handle the inbound request. And I have a zip in here. And while it's uploading, let's check what exactly this code will do, right? It's a TypeScript code, and it's not complicated at all. So the first thing, it will create an SQS client. It will decode our base64 that we received base64. Then we'll just send a post to SQL queue with the message, you type whatever, right? So it's really a simple code. No big mystery here, but there is an important thing here where it is. Please help me to find the environment variable here. I need to set this environment variable because I didn't want to fix the name of the queue here. So we are going to set this environment variable, and one thing else, my module calls handler, and for default here is index. So we need to adjust that. Handler, save. Okay, and now we just need to create our environment variables. So I have it already here. Outbound queue name. I can't have any space in here. And again, the name of the queue, the outbound queue that you're going to post, right? So we received a message from one queue, and this is the queue that you're going to post the message in. So the queue name. We didn't create this queue yet, so let's create it now. So let's come back to the diagram, always to the diagram, so the architect not get angry with us. We have this Lambda function, we're going to receive this and post in this. So we need to create also this queue. So let's do it. I have the SQS here. It will be really the same process that we did. So it's going to be a first in, first out, because I also want to answer in the same order. So this is the outbound queue, and we have an outbound queue right now. Okay, then. So my Lambda function is configured to work, but I need a trigger, right? Remember, Lambda functions are computing service for AWS that runs only when triggered, and we need to add a trigger for it. But before to add a trigger for it, just that message that we sent in the queue, let's remove it, because now that we have our Lambda function, we need a structure, and we'll keep getting error with this message that it's only test, right? So this is the inbound. Let's purge. So, okay, now, okay, I'm good. And let's create our trigger. And a trigger is going to be SQS, right? Because we are going to receive the message for the SQS. The inbound queue. Batch size. Here we are going to set 1, because my code handles only 1. Your production code needs to handle a batch with more than one message. So Here, for a matter of the simplicity for our demo, we are going to use a batch size of 1 and no batch window. So we won't wait. Every time that I receive a message, I'm going to run a Lambda. That's not cost effective, but it's for the demo, it's okay. Okay, then, now I have an SQS trigger. So let's try something different right now. I'm also going to use the postmoney here. So I'm going to minimize here, message to the bot. Remember, now I need to post something using the URL. Yeah. So let's get the API gateway URL that we have here, okay? Copy link address, and let's paste here. But what's the word that you need to remember? Batata, that's right. Batata. Okay, so I'll have my API here. Let's make a call. This is the template that Telegram will send and our function is expecting, okay? And we had the same message. So it's working. It's actually in the internet, receiving from API gateway, send to SQS. Now let's check if our Lambda function is processing it and posting to the next queue, right? Okay, so let's do it. We can go from the SQS, and let's see if we have a queue there. And actually, in the outbound queue, we have a message there. So if we go here, send your message, and pull for message, and actually have, hey, you typed hello. So what's going on? We send a message to our API gateway. Our API gateway posted to SQS. Our Lambda function received this message and posted to the new queue. So what we need now? Just to do this Lambda function to post to Telegram, right? But to post to Telegram, I need to have a Telegram configured. So let's create our bot. Let's go here. Where is my Telegram? So this is my Telegram. And this is the bot father. Let's go do this, and here. And here's the bot father. Actually, I have a bot to create a bot, and they are really good with names. I think it's really creepy, but yeah. So, new bot, it's easy. And he'll ask, okay, what's the name of your new bot? Yeah, the name of new bot, it's going to be WAES Tech Talk. Okay, great, Daniel, you have your bot, but what's the ID? Okay, this needs to be unique and needs to finish with bot. So, WAES Tech Talk bot. Okay, congratulations, Daniel, you have your bot. But here is the first concern, first and probably only concern that I have of security using Telegram. We have this token here. This token is the only token that will manage our bot. If someone is stealing this token, you are, I'm not going to say a bad word here, you are screwed, right? So we need to take care about that. And god damn it, the architect didn't drive it. I can't put this in the code, right? Because it's going to be the source code. So now you're going to blame the architect and being secure. No, we are experienced developers. We need to handle that. So let's store this, this token in a service that we can actually rely. Let's store this in the circuit manager for AWS, okay? So it's not in the diagram, then we are, oh, sorry, it's not in the diagram, but we have a circuit manager here, and then we can complain with the architect that didn't draw it for us. So let's go there, and here is my SQS. Let's go here. I don't need here anymore. Just go to the circuit manager, and we have it here. Okay, then let's store a new circuit. It's going to be that. This one, I'm going to paste my token here. And I already have my code prepared for that. So for my code, I will use, sorry, where it is, create Telegram box, circuit manager. So I need this here. We are going to use the AWS encrypting key. It's okay. Secret name. Remember, names are important here. Okay, then I don't need description. Blah 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 blah. Next, next, finish. So we have our key hosted in a secure way in AWS, right? So now I have my bot created, I have my secret manager. So let's create our last Lambda function. And let's go here and create our, it will be the same process that we did. So Lambda function name, come on GitHub, it's going to be this one. Again, Node.js 16, RM64, default role, use an existing, and let's get the role that I already have, configure it, and create our function. So we have created, let's upload the function code, zip file, upload, and here, this is now the outbound function because we're going to send message to the world, actually to the Telegram, but it's in the world, so let's do it. And application, right? Okay, while I'm saying this, let's show the code. What's actually doing here? So inbound, outbound, source, handler. Also, I will need to change things from index to handler. And what's doing here? Okay, I will receive an event that contains the message. I will parse the message. I will get the secret from the secret messenger, and I'm going to post it to Telegram. Simple, no secret here. So let's do it. Right, so let's change here because I need to change. Handler.handler. That's correct. That's correct. And also, sorry, I got the key for you to use in a secrets manager from the environment variables again. So let's go for the environment variables. Edit environment variable, and let's just copy for here because Telegram bot token. Just remove the space and WAES Tech Talk token. Yeah. Okay then, so we have our function done and configured. What we need to add? A Lambda function just works when it's triggered, right? So now the trigger will be also an SQS, but will be the outbound queue because now we are getting out the outbound queue and sending to Telegram. So let's do it. Again, same here, my code only handles one message. Your code should handle more than one. Actually, it's not should, but maybe too nice. So add. Okay then, I already had a message there, right, from our test. Let's take a look at the log. We actually have some time. Let's take a look at the log. Okay, go AWS, help me, quick, fast, please. Okay, no errors. That's good. Actually, the function is trying to send a message back to Telegram, but Telegram only allows you to to receive a message from someone for some bot that you already sent a message. We didn't that yet, right? So let's do that. But first, I was forgetting. Sorry. Remember that I said that I had 2 configuration steps: creating the bot and also setting to webhook. Right? So let's set to webhook. Unfortunately, we can't use the bot to that. We need to use Postman. Yeah, that's a shame. But we are going to set the webhook in here. And to set the webhook, it's really simple. We just need our key. Can I zoom in the Telegram, the Postman? No. So let's just remove this one. And again, let's get our key from Telegram bot. And we're here. So we are in the Postman. So let's paste here. Yeah, but something happened here because I should have this structure. So let's get this set webhook, and because I need to send for the Telegram the URL that I want, right? So let's go to Postman. Yeah, okay, and the URL I just need to remove here. Oh, sorry, this post-it. And now I'm just going to get the URL that for our API. And I said that we wouldn't use anymore, and I was lying. Yeah. Okay, so let's go here, and let's get from stage our production, and let's copy this one. Okay, now here, let's try. Webhook was set. Okay then. So now it's easy, right? It's an easy API that you can use from Telegram. So, okay, let's try our first interaction with our bot, if he's polite or not. So let's start. Okay, Telegram takes some time to set webhook, etc. But this is actually a message. Let's check what's happening with our infrastructure. Okay. Remember that our test, we say, hey, you say hello. It's already here. We already sent the message, right? You receive it. He was keeping trying to send the message. Now that I sent the first message, yeah, now my bot can also can actually send a message in there. Let's check here what's happening. And that's the time that the presenter just have a lot of afraid because we need to work, right? So let's go to our function. Let's see if we got any error in here from the inbound. Let's go to monitor, CloudWatch logs, because we need to see some interaction here. Invoke error, unexpected token JSON. Okay, so actually have an error in here. I don't know why. Let's check the queue. Let's purge. Just check. I don't know if I already purged it for the last time. Let's check if the time is going on here. No message available. And let's check our login here. Yeah, we have some errors in here. Okay. Let's check for the last minute. Let's just put 2 minutes. Okay, nothing here. So we are debugging production right now. Yeah, it happens, right?
Yeah.
So come on, AWS. Yeah, I think this is a Telegram issue. Since we are not receiving anything, let's try with the Postman. Message to bot. I saw Bing, and let's check what happened for here. Yeah, let's check. Probably we missed something with the webhook. Let's check here, set webhook. Let me go here if I can see, sorry. Oh, man, we forgot. What we forgot? The batata, man, we forgot the batata, come on. What a shame. Come on. No, I'm a bad presenter. I forgot the batata, man. Of course, this happened in the presentation, of course. Okay, now we have a lot of messaging here. Now the bot's angry with me because I forgot the batata, right? Well, let's just play here. So now it's working. And it only works because of the batata, right? So, okay then, it's working. Actually, you can have your cell phone, and if you have Telegram there, look for WAES Tech Talk, and you see that's working. It's not on my screen. It's not a movie. You see it. We found the data issue. But yeah, you can say everything you want. You can actually answer something with HTML5, some pictures or something beautiful, and yeah, it's really cool. I'm going to leave this bot working till the end of the day. So tomorrow it won't exist anymore. So if you want to, I don't know why, but if you want to play with this, yeah, that you can play it. But let's back to our presentation. So Gabriel, don't get angry with me because of the time. Here we have demo. We need to talk about cost, right? So this is the cost. Actually, I'm going to go for the. Can I click here? I really don't know how to work with PowerPoint. Okay. So let's do one thing here. Oh, yeah. Yeah, I accept the risks. And open this monitor, of course. And here is the cost for this bot for 1 million messages. So for 1 million host receiving processing 1 million of messages, 1 million messages, we'll have $13 maybe 37.3 of costs. You can see here that the major cost is the circuit manager, because this is the one that you pay without using. You pay 40 cents per month, and it's really expensive because we are reaching them every time that we go to the messaging. We don't want to do that. We can use another approach, but for the demo, it's simpler like that. Here, the lambdas. We are not using the free tier. Calculating with the free tier, it will be free for 1 million messaging. And this lambda is really big, have 512 gigabytes memory for processing, because for the lambda functions, when you get the memory increased, you get the CPU power increased. So if you need really process something, you need this. And this one is a really small lambda just to call Telegram, right? So this is actually the costing. It's really cheap. So you can have your bot that with really cost-effective way and reliable way in AWS, right? And that's it, guys. Thank you so much. Hope you enjoyed the presentation. If you have any questions, just reach me now or later, whatever you want. Thank you very much. Do you know if I have any questions in there from the audience or from the YouTube? Oh, picture. Now I need some water.
Yeah, I was taking notes of the of the questions that came. So the first question is from Tato. If you are scalable or not.
If I'm scalable?
Yes.
Yeah, maybe I have a limit, but yeah, maybe.
Okay. He has another question. You mentioned that special characters could break the JSON.
Yeah.
What happens in the inbound Lambda function code if that happens?
Actually, we need to use the reliability for the SQS. We need to configure that queue ladder. If you don't configure that queue ladder, you keep trying and trying and trying, or your code should remove the message from there. So you have the two options: or send the message to a dead queue ladder, or configure a code. Okay, just going to discard this message and not use anymore. You have two options.
Okay. So now you know what to do if the messages stop appearing. The other question is from Ericsson, and this, I think, is more technical. So he said that SQS has some limitations for processing real-time scenarios like this. So why not consider AWS IoT or MQTT and subscribe the Lambda to it? Do you think it might improve the scalability?
Probably we might improve the scalability, but I think it will be less cost effective. I don't know the price for IoT, and for the top IoT topic, I don't think that we have the same handling for FIFO or something like that. I know that because I'm using that, but not really sure if they work like a FIFO queue actually. So yeah, you can use Kafka in here, because you can connect Kafka to Lambda functions. It depends how much you want reliability, how much you want to scale, and how much you want to pay for it. So yeah, but certainly you can use another solutions like IoT maybe.
Okay. And then another question from Tato. If the token got stolen, what you can do?
Yeah, if the token got stolen, you need to delete your bot and create a new one. with the same name, with the same ID, but you need to do that. So unfortunately, we don't have really good.
Isn't there like APIs you can do like a kind of key rotation or something?
No, actually, at least not. I don't know. Probably I need to read the documentation. Yeah,
but you send a message to the bot, so maybe you can send a
Yeah.
message to the bot and do
maybe
this.
through the bot, because the creation of tokens with the bot. So that's why I think that that there isn't. But maybe if you read the documentation, we'll find a way.
Good. I want to thank you, Daniel.
Oh, thank you so much.
This was really nice presentation. I really enjoyed it. And with now with 2 presentations that you just have, so you can create your Telegram bot and make him post to your Saves API, and then you just connect with the bot and say like, okay, I saved this amount, and that's gone. So I really want to thank you both, and see you on our next Tech Talk.